Knowledge Bandara, an animated video presenting the world's best-selling books. Hello friends, welcome back to Knowledge Bandara. This week we will explore about cloud and on-premise, cloud computing deployment model, cloud computing architecture, and finally the challenges and benefits of cloud computing. Cloud computing is a model of delivering computing services such as servers, storage, databases, networking, analytics, software, intelligence over the internet, commonly referred as cloud. Cloud computing offers significant advantages over the traditional on-premises computing, including cost saving, scalability, and ease of use. So let's get into the video. On-premise computing and cloud computing are two different ways of accessing and utilizing computing resources. On-premise computing refers to the traditional method of setting up and managing an IT infrastructure within an organization's physical premises. The organization owns and maintains all hardware, software, and networking equipment, and all data is stored on local servers. In contrast, cloud computing refers to the delivery of computing services such as servers, storage, applications, and services over the internet. With cloud computing, users can access resources on demand from a cloud provider's infrastructure and pay only for what they use. The cloud provider is responsible for maintaining the infrastructure, ensuring security, and providing scalability. Next, let us understand cloud computing architecture. Cloud computing offers several service models which describes the level of abstraction and functionality provided by the cloud computing environment. The architecture of cloud computing is based on three primary layers: infrastructure as service, platform as a service, and software as a service. Each layer provides different levels of abstraction and functionality, and they work together to provide a complete cloud computing environment. Let's go deep and understand all three layers in detail. First, the infrastructure layer is the foundation of cloud computing architecture, providing the underlying physical and virtual resources such as servers, storage, and networking infrastructure. This layer is responsible for managing the physical and virtual infrastructure, including the allocation and management of resources such as CPU, memory, storage, and network bandwidth. Customers can choose the amount of resources they need and pay only for what they use. IaaS is particularly useful for companies that need to scale their infrastructure quickly and do not want to invest in expensive hardware. Examples of IaaS providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Amazon Web Services offers a variety of services including Elastic Compute Cloud, EC2, Simple Storage Service, S3, and Elastic Block Store, EBS. EC2 provides virtual machines on which customers can run their applications. S3 provides object storage for files and media, and EBS provides block storage for data. Microsoft Azure offers similar services including virtual machines, blob storage, and disk storage. Google Cloud Platform offers compute engine, cloud storage, and persistent disk. Second, the platform layer is built on top of the infrastructure layer and provides a higher level of abstraction than IaaS by offering pre-built application components, middleware, databases, and other services that customers can use to build and deploy their applications. PaaS customers do not have to worry about managing the underlying infrastructure and focus on building and deploying their applications. PaaS customers typically offer tools and services for building, deploying, and managing applications, as well as services for monitoring, logging, and scaling applications. PaaS providers offers a variety of services including web application frameworks, databases, and messaging systems. Customers can choose the services they need and pay only for what they use. PaaS is particularly useful for companies that want to focus on building and deploying their applications rather than managing infrastructure. Examples of PaaS providers include Heroku, Google App Engine, and Microsoft Azure App Services. Heroku is a cloud application platform that allows developers to build, run, and scale applications in a variety of programming languages. Google App Engine allows developers to build and deploy applications on Google's infrastructure using a variety of programming languages and frameworks. Microsoft Azure App Service allows developers to build and deploy web, mobile, and API applications on Microsoft infrastructure. Third, the application layer is the top layer of the cloud computing architecture, providing complete applications that are delivered over the internet. This layer includes software applications such as email, collaboration tools, customer relationship management, and ERP applications. SaaS applications are typically accessed through a web browser or mobile app and require no installation or maintenance on the customer's part. SaaS customers do not have to worry about managing the underlying infrastructure or developing their own applications and can simply use the applications provided by the SaaS provider. SaaS providers offer a variety of applications including email, customer relationship management, and productivity applications. Customers pay a subscription fee for the applications they use, and the SaaS provider is responsible for managing and maintaining the infrastructure and applications. Examples of SaaS providers include Salesforce, Dropbox, and Google Workspace. Salesforce is a cloud-based CRM platform that allows companies to manage their customer interactions and sales processes. Dropbox is a cloud-based file storage and sharing platform that allows users to store and share files with others. Google Workspace, formerly known as G Suite, is a collection of productivity applications including Gmail, Google Docs, and Google Sheets. The key difference between IaaS, PaaS, and SaaS is the level of scalability that they offer. IaaS provides customers with the most scalability as customers can easily add or remove virtualized computing resources as needed. PaaS also offers scalability, but it is limited by the services and components offered by the PaaS provider. SaaS providers typically offer unlimited scalability as they can easily scale their infrastructure to meet the needs of their customers. Cost is also an important consideration when choosing between IaaS, PaaS, and SaaS. IaaS is typically the most cost-effective option for customers who have the expertise to manage and maintain the infrastructure. PaaS can be more expensive than IaaS, but it offers a higher level of abstraction and eliminates the need for customers to manage the infrastructure. SaaS is typically the most expensive option as customers are paying for the complete application and the infrastructure and maintenance costs are included in the subscription fee. Next, we will see cloud computing deployment models. Cloud computing offers several deployment models which describe how the cloud computing environment is deployed and managed. The three primary deployment models are public cloud, private cloud, and hybrid cloud. A public cloud is a cloud computing environment that is owned and operated by a third-party cloud service provider such as Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Public clouds are accessible over the internet and are available to anyone who wants to use them. Public clouds are typically deployed on a pay-per-use basis, which means that users pay only for the resources that they use. A private cloud is a cloud computing environment that is owned and operated by an organization or a third-party provider, but it is dedicated to a single organization. Private clouds are typically deployed behind the organization's firewall and are not accessible over the internet. Private clouds offer greater security and control over the computing environment, but they require more resources and expertise to manage. Next, hybrid cloud. It's a cloud computing environment that combines both public and private clouds. A hybrid cloud allows organizations to use public cloud resources for non-sensitive workloads and private cloud resources for sensitive workloads that require greater security and control. Next, let us see the benefits of cloud computing. Cloud computing offers several benefits over traditional on-premises computing. First, cost savings. Cloud computing eliminates the need for expensive hardware, software, and maintenance costs. Customers can pay for what they use and can scale their usage up or down as needed. Second, scalability. Cloud computing allows customers to easily scale their infrastructure to meet changing demand. Customers can add or remove resources as needed without having to worry about the underlying infrastructure. Third, ease of use. Cloud computing eliminates the need for customers to manage and maintain their own infrastructure. Providers take care of security, backups, and other administrative tasks, allowing customers to focus on their applications. Fourth, flexibility. Cloud computing allows customers to choose choose the services and providers that best meet their needs. Customers can choose from a wide range of providers and services, making it easy to switch providers or add new services as needed. Next, what are the challenges or limitations of cloud computing? While cloud computing offers significant benefits, but it also presents several challenges, including security. Cloud computing raises new security challenges as customers must trust their data and applications to a third-party provider. Providers must implement strong security measures to protect customer data and applications. Second, compliance. Cloud computing raises compliance concerns as customers must ensure that their applications and data comply with regulatory requirements. Providers must offer tools and services to help customers meet their compliance obligations. Third, performance. Cloud computing can suffer from performance issues due to network latency, bandwidth constraints, and other factors. Providers must offer high performance infrastructure and tools to help customers optimize their applications. Fourth, vendor lock-in. Cloud computing can lead to vendor lock-in as customers become reliant on a single provider for their infrastructure and applications. Customers must carefully evaluate providers and services to minimize the risk of lock-in. In summary, cloud computing is becoming increasingly popular. In today's world, it is being adopted by organizations of all sizes and industries. With its many benefits and advantages, cloud computing is expected to continue to play a significant role in the future of computing and technology. Hope you have liked this video. Please subscribe and support for more such technological related videos. See you in my next video. Bye.